right, so guys, like I said, 9.1 is kind of where things are going to start to get a little tricky for us when we start talking about some identities here. And this sheet is going to have a lot of rules on it that you're going to want to refer to in terms of the identities that we're going to deal with. But 9.1 is titled Using Trig Identities. How about a volunteer to read this for me?
How can you verify a trigonometric
Trigonometric.
yeah. Identity?
Yep, how do you verify it? Guys, verify right here means to show.
Yeah, seriously, like that concept.
It's going to mean to show equality, all right? Okay, it's going to mean to show something is equal to something else there. That's what verify is going to mean today, all right? And there are tons of rules that we're going to refer to. And, you know, if we memorize them, awesome. But I've been doing math for a long time, and I still don't have quite all the memorized. So I've got to use some of the rules to come back and look at, okay? So our goals today, kids, we're going to use trigonometric identities to evaluate trig functions and simplified trig expressions. We're also going to verify trigonometric identities. So, that said, let's see what some of our vocab is today. I think the vocab is kind of short, isn't it?
Yep.
Okay. Trigonometric identity. I need to do something real quickly. This is moving kind of slow, so give me 1 second, okay? Okay. So guys, right here, a trigonometric identity is going to be an equation that is true for what here? What's it say?
All values.
For all values of the variable for which, this should say both sides of the equation are defined, okay? I gave you a couple of examples up here, and we'll talk about why they are the way they are, but one of the most famous trigonometric identities is this. We would say sine squared plus cosine squared for any theta value will always equal what? 1. Or a sine of pi over 2 minus theta is the same as what? And we'll show you why as we progress through the chapter here. But guys, we're kind of saying, if you ever see sine squared plus cosine squared, what could you replace that with? 1. Or if you saw sine of pi over 2 minus theta, what could you replace that with? We're going to be doing a lot of that, replacing with equivalencies as we move through this chapter, okay? And then the unit circle, you guys still have that already?
Yeah.
It's the most important note sheet that I can give you with special angle values, okay? All right, let's start talking fundamental trig identities, okay? Reciprocal identities are pretty important, okay? We've talked about these actually already. What's the reciprocal of the sine function, kids? So it's like 1 over the what? Okay, the sine would be the same as 1 over what? So if I want to replace sine with something, I could call it what? If I ever saw 1 over cosecant, I could replace it with what? Okay, let's just run through these right here. Cosine is equal to 1 over what? Tangent's equal to 1 over what? Cosecant, that would be equal to 1 over what? Secant would be equal to 1 over cosine, and cotangent would be? Okay, what kind of identities are these called? They're just reciprocals of each other, okay? They're just reciprocals of each other. So, we should be good with that, okay? Some tangent and cotangent identities. These are important, okay? Guys, if you ever see tangent, the tangent can be defined as what over what? Sine over cosine. And your cotangent can be defined as what? Cosine over sine. Okay? Now that first page of stuff, those are pretty basic and pretty easy. Alright? We start running into troubles where things get a little more difficult on the next page. So if you'll flip there. Oh my goodness gracious. Is the next one Pythagorean identities?
Yep.
Okay. This, my friends, is important. I'm going to kind of put a little squiggle line right here. There's 3 basic Pythagorean identities here. You might want to drag this all the way down like this. Okay? Okay, so I'm going to make some extra notes about Pythagorean identities. Okay? They give you 3 up there, kids, but there's some things that we can do with this. All right? You're going to see some things like this here. So the extra notes I want to add to the Pythagorean identities is this. First of all, this says sine squared plus cosine squared is always equal to what value?
1.
Okay, let me ask you this question then. What would sine squared equal if I wanted that to be alone?
1 over cosine.
If I wanted to get sine squared alone right here, what would I have to subtract from this side?
Square.
Subtract cosine squared from both sides, right?
Yeah.
So just because this identity is like this, if you don't see something exactly like this, that doesn't mean that you can't use it, because if I manipulate this a little bit, I could say, you know what, if I want sine squared to be alone here, that could equal 1 minus what?
Cosine squared.
Cosine squared. Okay, so there's another Pythagorean identity that really comes from manipulating the original one. Okay, does that make sense yet? So what would cosine squared be equal to? If you ever see cosine squared, you might be able to replace it with what?
1 minus sine squared.
Okay. So really, I see 3 Pythagorean identities up there, but how many think they're going to be totally? They're going to be 9 of them. They're just going to be written in different forms, aren't they? Okay, so this here says 1 plus tangent squared is equal to what? Okay, well, let's do this. Could I say secant squared minus tangent squared would equal what value?
1.
Okay, so let's do this. Secant squared minus what? Okay. Okay. Let's see, what else could I get alone? Could I get tangent squared alone? What would tangent squared equal then?
Secant squared minus 1.
Tangent squared would equal secant squared minus 1, you say?
Yes.
Okay. All right. And we'll talk about these proofs here in a little bit. Guys, what's the last Pythagorean identity they have up here? Equals what? Okay, give me another one from that we could form. So cosecant squared minus cotangent squared equal 1. I forgot to put the u's in there. The u is just like the angle. Okay, so make sure you get your u in there. So cotangent, or I'm sorry, cosecant squared u minus cotangent u would equal what value again? Okay, what's the other one then? Cotangent squared of u equals cosecant squared. Okay. All right, very good. Okay. Pythagorean identities. We put some extra notes on there. We said that the tangent and cotangent functions were important, right? Okay, very important here. So have you guys got those?
Yes. Yeah.
Hey friends, let's roll. There's also some cofunction identities. Now guys, what value do you see in all of these?
U.
Pi over 2 shows up everywhere, right?
Yeah.
Okay, the giveaway for a cofunction identity might be that within parentheses, what value exists there. Okay, let me show you what they're talking about right over here. Guys, what's the first identity they give you?
Sine.
Okay, so they say the sine of what?
Pi over 2 minus u.
Equals what?
Cosine.
Let me just show you what they're even talking about here, okay? So if I jump into decimals, friends, again, we talked about for verifying these identities, we need to show that they, what are we trying to really show here again, kids? What did we put on the very first page? They're equal, okay? And if they're equal to each other, wouldn't the left side graph out to be the same as the right side? Okay, so if I go sine, what did you say, pi over 2?
Yep.
I'm going to use minus x, is that okay?
Yeah.
There's that graph. And then that should be the same as the cosine of what? Well, what do you say? Here's the, if I get rid of the cosine, there's the sine. So what's true about these two functions? They fall right on top of each other, don't they?
Yeah.
Okay, so friends, the giveaway is what value in all these?
Pi over 2.
You see pi over 2 minus something here. You can change it to any of these up here. So sine of pi over 2 minus u is what? And moving forward, that's all right there. Do I need to read through them, or can you find it? Okay, so the giveaway is what value in parentheses? Pi over 2. Okay. Then, friends, we have some negative angle identities saying like this. If you see sine of negative x right here, that's the same as what? Okay. Cosine of negative x is what? Cosine of x. Tangent of negative x is what? Negative tangent of x. Okay. Cosecant negative x is what? Okay. In each case, don't all these have negative x in all the parentheses?
Yeah.
So the giveaway might be, if there's a negative x in there, we might want to replace that with something different. Okay, so the negative angle identities, the giveaway is the, okay, are you with me on this?
Yeah.
Okay. Well, my friends, let's see if we can't find some trigonometric values here, friends. First problem is kind of about things that we've done in the past, okay? All right, we've talked about this a little bit. It says, given that sine of theta is equal to what?
Negative pi over 13.
And theta is greater than what value here?
Pi.
But less than or equal to what?
3 pi over 2.
Now keep in mind, these are radians. You guys agree with that?
Yeah.
Okay. Let's just talk about our coordinate plane again. Okay. You guys agree 0 radians is right here? Okay. What's this? You remember in radians?
Pi over 4.
Pi over close.
5 over 6.
Okay, think about that. Isn't that 90 degrees?
Yeah, it's.
So if I went 90 times pi up top over 180, doesn't the 90 and the 180 become 1/2?
Oh, yeah.
Remember that?
Makes sense.
Okay, so over here, this would be 180 degrees, which would just be
Pi.
pi radians. You might want to make sure you draw this chart, and then down here would be your,
3 pi over 2.
okay. So kids, when they say, hey, your angle theta is between pi and 3 pi over 2, which quadrant are we going to lie in? Third quadrant, right? Okay. So right here in the third quadrant, I'm going to just draw this right down here. Okay. Now, your triangle always has to form a right angle with which axis?
X.
It's got to form with the x. Again, I still saw some people on the test yesterday. I don't think anybody in here did it, but they wanted to form their triangle down here with the y-axis. Is that the right thing to do?
Nope.
No. Make that right angle up here with the x-axis. Friends, where's theta going to lie then? The origin. There's theta. Okay. So we know we had to be in the third quadrant given these parameters right here, right? Okay. Guys, what do they tell you the sign is?
Negative 5, 13.
-5 over 13. So again, we've talked about this already. By definition, friends, what is the definition of your sine function? What over what?
Opposite over hypotenuse.
Okay, so opposite leg length has to be what value according to this ratio up here? This has to be -5, and then the hypotenuse would be what? 13. Now we got to be careful on this, kids. You guys know the relationship for 5 something else and 13?
Yep, 12.
12. But guys, this 12 here, if you use Pythagorean theorem, you'd get 12. But guys, I'm going left of the origin. So what kind of a 12 should this be right here? Okay, so let's talk about it, kids. The good part is this. You already knew the sine of theta was what, friends? Okay, so by identity right here, what's the reciprocal of sine? Cosecant must be what value? Okay, and I'm going to keep my negative up top. Is that okay with you guys? Okay. Do I have enough information then to work with the cosine? Okay, what's the cosine going to be in that diagram?
Negative 12 13.
-12 over 13. Guys, what's the reciprocal then of the cosine? Or the reciprocal identity for cosine? Secant. So secant has to be. Guys, I think this question was on your test yesterday pretty much, wasn't it? No. Hey, I have to hand those back. And by the way, how many have to finish that?
I have not finished.
Okay. Try and find some time, okay?
Yeah.
All right. So this will be negative 13 over 12. Okay. What do you want to find next, friends? Go tangent. Now tangent's going to be a negative over a negative, so what's really going to happen here? And that's why the tangent is positive down here in the third quadrant. So it'll be 5 over 12, you guys agree?
Yep.
Which makes the cotangent what? Okay. So we've had enough exposure to that kind of stuff right there. The thing that's kind of new for you is this now. They're telling you the sine's going to be negative 5 over 13. We don't know where that would have been. So when I tell you this right here, what is this identifying right here that we circled? That's going to identify which quadrant you had to fall in. Okay? We could have had a sign of negative 5 over here. Couldn't have negative 5 fallen over here, going downwards like this for that vertical side. All right? But by them telling us this allows us to say, okay, we're in the third quadrant, therefore that's why that 12 had to be what kind of 12, friends? Negative. Okay? All right. Well, once we know sine, cosine, tangent, you know enough about reciprocal identities to do that. So, questions on example 1 at all? Feel okay with that? Okay. Well, let's take a look then at the next page. Dun, dun, dun. Oh boy. My friends, let's see what's going on here. This says simplifying trigonometric expressions, okay? Now, this isn't the worst thing in the world to do, but it's certainly not the easiest thing in the world to do, okay? I sometimes say simplifying is harder than verifying because people don't know when to stop, okay? You might get an answer, be like, is that good enough for us? It's like, I don't know, okay? Here's the deal. When you look at these right here, how many terms are in this example on the far right, for example? 2 of them. Idealistically, if I wanted to combine them or make this simpler, idealistically, instead of having 2 terms, if we could simplify it down to, that would probably be the best, right?
Yeah.
Now here's the problem. One simplification is not always going to be the best. One term, you may not be able to get to 1 term sometimes. Okay? You might be at 2, all right? You just got to keep yourself asking, can I make this any simpler? Okay? So let's try this first one. Do you guys agree that this looks like a binomial times another binomial? That we could use what on here? We could FOIL this out, right? Okay, let's talk. What's 1 times 1 going to get you?
1.
Okay, there's 1. So let's write that down. This becomes 1. Okay, and then 1 times negative cosine theta would be what?
Negative cosine theta.
Minus cosine theta. Okay, let's do the insides. Cosine theta times 1 would be what? Ooh. Would that be plus cosine theta? Okay, and then my last one, what's this going to be? A cosine times a cosine would become what? Okay, this is actually going to be called cosine squared. The theta won't change, so we're going to call this, and be careful on this. First of all, it's going to be a plus or minus when I do that last one.
Minus.
Okay, this becomes minus cosine squared theta. Now take a look at where we're at right now, kids. Anything that we could do to make this a bit simpler?
Cancel out the middle.
Okay, the cosines to the first degree cancel. Now understand this. Is cosine squared the same as cosine to the first? No. One's a negative cosine, one's a positive cosine to the first power. These will cancel right here. I agree. Okay, now what are you left with? 1 minus what?
Cosine squared theta.
Okay, now guys, you're doing pretty good right here. If you got that far, I'd say that's pretty good. Okay? The thing I want you to understand is we end with a 1 and we end with a cosine squared. Okay, which of the identities had a bunch of squaring in them? Which form of identities had a bunch of squaring in them? Pythagorean identities. And go back to your extra notes there. Do you see where I could maybe take 2 terms of 1 minus cosine squared and call it something different?
Yep, you can call it sine.
You guys see that part where we wrote 1 minus cosine squared theta?
Yeah.
Yep.
What's that also equivalent to?
Sine squared sine.
So now instead of having 2 terms, we're down to what?
1.
1 term. Okay, and when we get down to 1 term, pretty good chance that that's in what form? Simplest form. Okay, let's try that. So this would be in simplest form, sine squared theta. Okay, holy cow. So if you ever see 1 plus cosine theta times 1 minus cosine theta, you'd be like, ooh, that's the same as what? And if I was in an equation, what could I replace that with? Okay. All right, next one. Let's talk about the next one. You guys maybe talk me through this right here a little bit. I'm going to take a seat here. First of all, what two functions are we using up here? Tangent and what? So my friends, are there any special rules about cotangent and tangent?
Yeah. They are reciprocal.
They could be reciprocals of each other. Was there any like fundamental rules for just cotangent and tangent themselves? Was that its own section maybe?
I don't remember.
I think we put the word important by it.
Oh, yeah. And, okay, so, wait. Tangent equals sine over cosine.
Okay, let me go back to the first page right here. So I think the one you're talking about is right here, isn't it? This important one? The tangent could be rewritten as what over what, kids?
Sine.
And this could be written as what over what?
Cosine.
Okay, let me show you how this one's going to simplify. Again, it would be ideal if I could take two terms and get it down to what? One term, okay? Guys, I'm going to tell you, 99.9% of the time when you see either tangent or cotangent, they want you to write it as sine over cosine or what? Okay, the way I remember how to do it is this: cotangent, cosine is up top, the C and the C, all right? Okay, tangent is just what over what?
Sine.
Okay, all right. Here, page 3 is where I need to get to, right? By the way, what time's this in today? Anybody remember? 39, is that right?
Yeah, it's 39.
So let's rewrite the cotangent of theta as something else. This would become what over what right here?
Sine over cosine. No, cosine over sine. Oh, we'll take it back.
Okay, so we're turning this into cosine of theta over what?
Sine.
Plus what?
Sine over cosine.
Keep wanting to say sine is sin.
I know,
Okay.
I'm good at that too.
Cost, sin cost.
You know what else is a sin?
Yeah.
Any Minnesota sport that I pull for.
Hey, you know what? Are the Twins that bad this year?
They have gone from first place to last place in 4 days.
Oh my.
Zip it, Buck Rogers.
How was that possible?
Okay,
I like the Braves.
that's all right.
Person, what's on your socks? Sharks?
Sharks today.
It matches the shirt.
Okay, I forgot. My wife made fun of me. She's like, "You didn't wear those socks at track practice." And I looked last night. I forgot to change my polka dot socks into my track socks, and I was wearing polka dot socks at track practice last night. Kind of funny. So guys, here's the deal. We've got two fractions right here. We'd love to add them, but I can't do that unless what? Same denominator. Okay, so you guys are going to get a common denominator. I've got sine over here and what over here? Cosine, right? So the common denominator would have to be sine times what? So here's what we end up doing. We multiply this one over here by cosine of theta over cosine of theta.
Oh, looky.
That makes sense to you? And this is going to get multiplied by what over what?
Sine over sine.
Sine of theta over sine of theta. Isn't that a form of 1 that we're really multiplying by, guys? One thing over the same thing would be 1, wouldn't it? Okay, so check this out. What's cosine times cosine going to come up top here then?
Cosine squared.
Over what? Well, let's just do it this way. Plus what up top, I guess, really? This would be what?
Sine squared.
And then this is going to be over the common denominator, which is what?
Sine times cosine.
Cosine theta times sine theta, right? Now guys, the dead giveaway for simplifying this should be, ooh, I see some cosine squareds and some sine squareds. Anything special about cosine squared plus sine squared there?
I have no idea.
You go to your Pythagorean Identities. It's 1, isn't it? Anytime you see cosine squared, this will be the most famous one. Okay, cosine squared plus sine squared is 1. Guys, remember what two values were on the unit circle? The only two values you could get off the unit circle were what and what? Cosine and sine. Your cosine was like an x value, your sine value was like a y value, and it became like x squared plus y squared was equal to 1 squared. Okay, and 1 squared being what value? We simply replace the x with cosine and the y with sine. This basically is just the Pythagorean theorem when you have a radius of 1. It's a unit circuit value, or a unit circle value. So guys, am I down to one term here now, guys?
Yep.
1 over cosine theta sine theta. Anything else I can do?
Nope.
Not really. Okay, and that, my friends, would be your simplest form. Okay? Looks like a loaf of bread.
What did you just say?
I don't know. Looks like a loaf of bread.
Oh.
Okay.
I wouldn't look at that.
Oh, you don't see it?
That looks like some white niche form. I feel like some loaf of bread looks a little bit different, but.
Well, my loaf of bread is weird then, I guess.
I mean, when you homemade bread, maybe.
My
No, that
little
looks like some overproof white niche.
That looks like that should be my logo on my track shirt tonight when I run.
Oh.
Yeah. It'd look pretty cool. Fill it in with orange. Orange is my favorite color.
What shade of orange though?
Wait, are you coming to our track meet tonight?
No, Ruby has a meet tonight in, Grundy Center, so I'll be at Grundy Center tonight.
Grundy is really good, dude.
Huh?
Grundy's actually really good. I thought they
Yeah.
were gonna be bad. I was watching.
Alright, friends.
Yeah, Connor. How did my cousin do?
What's his? I don't know.
Ethan, you ran the mile.
Oh, I couldn't tell you.
Oh, you did?
I know that in the 4x4, I saw. What's your boyfriend's name? Yeah, Asher beat him. No, it was like really close. It was pretty fun to watch though.
Not to scare you, but this, no.
What?
Not too scary.
Okay, here's the deal, kids. This is where things maybe start to get a little bit tricky, okay? Okay. I don't know how to tell you this more than anything else, but here's the deal. It says verify the identity, okay? So this is where kids get hung up, and I'm not sure why. What they want to try and do is solve for theta. You see an equation with an unknown in it, kids are like, ooh, I got to figure out what theta is to make this work. Well, what I'm going to tell you right now is this works for any value of theta, okay? What you're really doing here, verifying an identity, is basically doing what we did right up here. What did 1 plus cosine theta times 1 minus cosine theta have to equal in the end here in simplest form? Okay, didn't we do some work here in the middle to get down to that simplest form?
Yeah.
If I would have said this is equal to, if I would have gone up here and said this is equal to sine squared theta like this, to verify something now, kids, they're not saying solve for theta, they're saying show me the work to get from here down to here. So in other words, you pick like one side to work with. You do the work, and then you end here, which is the other side. You're kind of doing the in-between work between the two. There's a start. This, and there's an end over here is equal to this. You've got to perform the steps in the middle to show that the two parts are equal to each other. And the best way to verify that something is an identity here, kids, I usually tell kids to pick the side that typically looks like it's the easier of the two sides to work with. Now, guys, that's not always going to be true, because over here, what appears to look like the easiest of the two sides? Okay?
It's not.
So this one here might be, maybe it's to our advantage to start with the trickier side and see if we can get to this side. Here's the deal. It doesn't matter which side you pick. Okay? So let's do this. Let's just actually pick the tricky side over here. Guys, listen to what I say. What two functions are we best at working with? Sine and what? Cosine. It would be really great if I could get stuff in terms of what first? Sine and cosine. So let me ask you this. We're going to start with the left side over here. We're going to work with this side to try to get to where? Okay. Is there any way you can rewrite secant of theta? Yes. Oh, okay. Well, we're going to start with the left side. I'm going to put a check mark over here. We're going to start with the left side. So,
Oh wait, I don't think that's helpful.
okay, 1 over. Is secant equal to something?
1
1 over. Okay, 1 over cosine.
Now this makes sense why we learned other things before this though.
Yes.
It's crazy.
1 over cosine, oops, I didn't want to do that. Minus what, friends?
Minus sine over cosine.
Minus, okay, tangent can be replaced with what, kids?
Sine over cosine.
1 over cosine.
Oh, yeah, cosine's on the bottom.
Oh, okay, so I have a question here.
I'm in.
1 minus sine.
What do you notice about the denominators down here?
They're equal.
So I'm going to kind of call that my first step. I'm going to try and make some room up here. Give me a second.
Is it sine theta or is it?
Okay. So do you guys now agree? I'm going to change colors to go to another step. Do you guys agree this is really the same as 1
Yes.
over? Okay.
Isn't it one?
These denominators are the same right here, right? So can I call this 1 minus sine of theta? I forgot the theta up here, sorry about that. 1 minus sine theta, like that, over what?
Cosine.
Okay. Ooh, I got an idea. Wanna hear it? Guys, does this look like a complex fraction to you?
Yes.
If I take a 1 and divide it by a fraction, it's like taking 1 and multiplying by the... Okay, so here what I'm going to say next is this. I'm going to change this into 1 times the reciprocal of this, but wait a minute. Isn't this like... I got an idea, you ready?
Divided by a fraction.
It's like dividing by a fraction, so wouldn't really, like, what's the reciprocal of like 1 over 2?
2 over 1.
So what's the reciprocal of 1 divided by this mess? Wouldn't it be this just flipped around?
Yeah.
So isn't this now the cosine of theta?
Cosine theta over 1 minus 7.
1 minus what?
1 minus sine theta.
Okay.
Times 1.
Have we gotten here yet?
Nope.
Maybe it would have been easier to start with this and see if we can get to...
Probably, but.
Probably would have been, but here's the deal. Okay, I want to show you something that pops up here. And this is going to be our last example today, and I'm going to let you go, all right? I want you to kind of remember something that we've talked about in the past. Remember conjugates?
Oh,
If I have 1 plus x, what's the conjugate of 1 plus x?
x plus 1.
Close.
Darn it.
It's not 1 plus x, it's...
1 minus.
And when you actually FOIL these out, this just becomes 1 minus x squared like that. Okay, because the positive 1x in the middle and the negative 1x on the outside would do what to each other? They would do what? Okay. Anytime, kids, anytime you see something like this, with the situation we're in right now, down below we have 1 minus what?
Sine theta.
We have 1 minus sine theta. That 1 minus a trig function is a dead giveaway to use a conjugate. Okay, what we're actually going to do is multiply both the top and the bottom now by 1 plus sine of theta. Okay, and let me show you why we're doing this. Okay, up top, help me distribute. I'll show you where it, oh my gosh. That was a bad line. Well, this thing doesn't work well anymore.
Oh.
Okay. Help me out, guys. What's cosine of theta times 1 on top there?
Cosine of theta.
Okay, so we're at this, what in the world? We're at this point right here. We are at this point right here. The top, if I would distribute, would become cosine of theta plus
Cosine times sine.
cosine times sine theta. Cosine theta, sine theta. Okay, now I'm going to cheat this a little bit. Do you guys agree that down here, when I FOIL out conjugates, this would just become 1 minus what, kids? 1 minus sine squared, right? Ooh, well, but 1 minus sine squared, wait a second.
We know what that is.
Take a look at your Pythagorean identities again.
Well, we have those memorized eventually.
Eventually you'll get there, and about the time you get them memorized, then we'll go on to something different probably. The bottom is really what, kids? The bottom is really cosine squared, right? So here's where things get kind of interesting. Okay, this becomes a cosine of theta plus cosine of theta sine theta over what again, kids? Okay, now watch what I do here, kids. I'm going to put cosine squared theta down here. But here's the deal, okay? Can't this cosine take that one out and this one out up here? So watch what happens here. I could kind of go back to what we were at up here, where we had cosine up here times 1 plus sine theta. This cosine would go away, and you would have one cosine. So what's we're going to do is we're going to factor some things out. This cosine could take this one out and what else out? Watch what happens here. But if I take one out up here, how many do I have to take out down here? Take one out, right? This is now like 1 plus what up top, kids? But hear me out. If I took the cosines out up here after I factored them out, how many do I have to take out down here then? So that means the common denominator now is what?
Wait, where'd you get the plus 1?
Okay, so hang on. This one right here?
Yeah.
Okay,
Well,
so
the one in front of the sin that you just got down. Yeah.
cosine divided by cosine would be what?
Okay.
1, right? And then you would have an extra cosine left here, right? One cosine would take one out here also, right? So this is like sine theta over cosine theta now, right? Check this out, kids. 1 over cosine. 1 over cosine equal anything?
Oh, we just figured it out, because sine is a cosine's tangent and 1 over cosine.
1 over cosine anything?
Yeah.
Sine over cosine anything? Did we get to where I wanted to get to? Okay. The job is not so much to say, oh, those are equal. The job is to do what? Show that they're equal, okay? And it's going to take some time. Now, kids, I don't want you to panic. I'm going to work with you a lot on this because this is going to be very new for you. And trust me, even I get a little confused on this sometime, and I'm going to help you as much as I can, okay? Questions at all, kids?